Hello everyone, so here are your notes for 8.1 Similar Polygons. Let's begin with the definition. Similar polygons have the same shape but different sizes. So if we take a look at the two shapes that we have down below, we have triangle ABC, and we also have triangle DEF. Notice how they are the same in regards to their shape, but one triangle is larger than the other, or you can say one triangle is smaller than the other. But regardless, these two triangles are similar. And so to write a similarity statement, we're going to go ahead and we're going to use this symbol. It's a little squiggly. It's actually called a tilde. And when we see this symbol, we read it as is similar to. Now let's go ahead and let's name these two triangles. I'm going to first go ahead and mark up the angles using some colors. It'll become important in just a moment. Now, I have on the left side, I have triangle A, B, and C. And triangle ABC is going to be similar to the larger triangle. But here's the thing, when I name it, I need to make sure that I match the corresponding angles. So angle A is going to correspond with angle D. And angle B is going to correspond with angle E. And of course, last but not least, angle C will correspond with angle F. So now that I have everything marked, we're going to go ahead and fill in the name, starting off with D, and then E, and finally F. So this is the correct way to write this statement, making sure that every angle that corresponds is in the same place in the naming. All right. Now, there are two things that we need to note regarding similar polygons, two properties that they have. The first property that they have is the fact that they have congruent angles. And we've already gone ahead and marked all of them in the triangles. So let's go ahead and let's list them. Angle A will be congruent to angle D. Angle B will be congruent to angle angle E, Angle B is congruent to angle E. And the last one, angle C, that one is congruent to angle F. All right, so that's the properties regarding the angles. There's another property regarding the sides. And the sides are not congruent. The sides are proportional. So when we see this word proportional or proportions, we need to write a fraction. That fraction actually represents the scale factor. So if you recall from chapter 4, when we did dilation, we had something called a scale factor, K. K tells us how much larger or how much smaller one shape is compared to the other. Now, we also worked with image and pre-image. Image is the shape that we get after transforming the pre-image. So according to the naming right here, the second polygon is always going to be our image. And our first polygon, the polygon on the left side, is always going to be the pre-image. So this is the original shape before it got either larger or smaller. In our case, from triangle ABC to triangle DEF, we have an enlargement because we went from smaller to larger. As for the scale factor, keep in mind that we always write it as the image divided by the pre-image. So taking the lengths of the sides. We're going to go ahead and take from triangle DEF, because it's the image, we're going to take side DF, and we're going to divide that by the corresponding side. Now, you can, of course, take a look at the triangle. It's going to be side CA, or you can use the name. I used F and D, the first and the last letters in the name, which means I'm going to use the last letter C and the first letter A. So CA. And this is going to be equal to another fraction, another ratio of the sides. This time, let's go ahead and let's use ED, which corresponds with BA. And then, of course, the very last ratio that we have is going to be from side FE to side BC. All right. And there you have it. That is the definition of similar polygons, along with two very important properties. Once more, just to reiterate, angles are congruent, sides are proportional. All right, let's go ahead and take a look at example 1. So it says in the diagram, triangle RST is similar to triangle XYZ. They want us to find the scale factor from triangle RST to triangle XYZ. So the first thing that we want to note is the fact that triangle XYZ is our image and triangle RST is our pre-image. And the scale factor always goes from the image to the pre-image. Now, how we're going to find that scale factor? We just need to pick a pair of corresponding sides. It really doesn't matter which pair you pick. If I chose side YZ, then I need to go ahead and choose side ST in the other triangle to make sure that we have the corresponding sides. So side YZ corresponds to side ST. Now all we need to do is substitute the values in. YZ is 18 units long divided by ST, which is 30 units long. Scale factors are always written in simplified form, so I need to go ahead and simplify this fraction. I can divide both the numerator and the denominator by 6, and that reduces to 3 divided by 5. And this right here, 3/5, is our scale factor. All right, Part B. Part B asks us to list all pairs of congruent angles. If you're having difficulty looking at the triangle and doing that, again, just refer back to the naming up at the top right here. I have angle R, and because angle R is the first letter, I need to match it with angle X, also the first letter. Then we have angle S is going to be congruent to angle Y, both of them are the second letters. And last but not least, angle T will be congruent to angle Z. Both of those are the last letters. Last but certainly not least, they want us to write the ratios of the corresponding side lengths in a statement of proportionality. This is just another fancy way of saying write all the fractions for all of the sides. So we actually already have one of the sides written as fractions. That was YZ divided by ST. And this will be equal to, now we just need to choose a different pair of corresponding sides. I'm going to go ahead and choose YX, which corresponds with SR. So YX divided by SR. And this, of course, is going to be equal to side XZ corresponding with side RT. So XZ divided by RT. And that's it. All right, go ahead and pause the video here and see if you can give this one a try on your own. Alrighty, go ahead and double check over your answers. Keep in mind that the image is going to be triangle PQR, which means that the side length that you pick needs to come from triangle PQR. Second thing to note is to make sure that, again, all of the sides down in your statement of proportionality come from triangle PQR. These might be a little bit out of order. For example, this fraction right here might be in the middle. This fraction right here might be on the side. But regardless, so long as the numerator and denominator are correct, you are good to go. Alrighty, let's move on to example 2. So in example 2, it says in the diagram, triangle DEF is similar to triangle MNP. Find the value of x. The first question you want to ask yourself is, what does x represent? Here, x is labeled on the outside of the triangle, which means that x represents how long side EF is. So, x represents a side, and what we know about sides for similar polygons is the fact that they are proportional. So in order to solve for x, I need to set up or write a proportion, which uses two fractions. Now, what we put into those two fractions kind of depends. One of the values that we need to include, of course, is the side that contains x. So we definitely have to use side EF. And now I need to find the matching or corresponding side to EF. Side EF in the name is the last two letters here. So I need to use the last two letters in the other triangle as well. Side EF corresponds to side NP. Now, as for the other ratio or fraction that we will write, it doesn't really matter which pair of corresponding sides you pick. What does matter is that both of those sides need to have a measurement. So if you pick a pair of corresponding sides and you're missing a measurement, ignore it and then move on to a different pair. Okay. All right. So in our case, though, like I said, it doesn't necessarily matter this time. I'm going to go ahead. I'm going to pick side DF and correspond that with side MP. Notice how in the numerator, EF and DF come from the same triangle, and NP and MP also come from the same triangle. So make sure that whatever you write in the denominator is the same polygon, and whatever you write in the numerator is also from the same polygon. Now we just go ahead and substitute in. X is going to substitute in for EF. For NP, we're going to go ahead and write down 30, and this will be equal to DF, which is 20, divided by MP, which is 24. If you would like to, you can actually go ahead and simplify this fraction, but I'm going to go ahead and just cross multiply from here. So when I cross multiply, I get 24 times x, which is just 24x, and this is going to be equal to 30 times 20. Putting that into a calculator very quickly, if you don't know what that is, 24x is equal to 600. Last but not least, I'm solving for x. This says 24 times x, so I need to divide on both sides by 24. So finishing up the problem here, 24 divided by 24 becomes 1. I'm left with just x is equal to 600 divided by 24, which is 25. All right. So that right there is how we use proportional sides to solve for a variable. Alrighty, if you would please go ahead and pause the video here and give this one a try on your own. Alrighty, go ahead and double check over your answers. Again, make sure that your numerators, the sides that you use in the numerator, come from the same polygon. And the values or the sides that you use in the denominator also come from the same polygon. Cross multiply, and then go ahead and solve all the way down to x. Alrighty, so in example 3 asks us to write a similarity statement and solve for x and y. So first things first, to write a similarity statement, we need to go ahead and name each of the polygons and put it in a statement. So let's see here. We are going to go ahead and let's just use the marks of the angles and go in order. So 1 mark is B, 2 marks is A, and 3 marks is C. So I have triangle BAC, and triangle BAC is similar to, again, making sure that the number of the arcs match. So B had 1 arc, U also has 1 arc. So we need to start the second triangle with U. 2 arcs are both A and T. And then finishing this up, the last letter, of course, is E. So that right there is our similarity statement. Now that we have our similarity statement, we can go ahead and begin solving for x and y. Now, we need to do this one at a time. So let's first focus on x. The first question, as always, is to ask yourself, what does x represent? X here is actually in an expression that represents angle t. So x for this problem represents an angle. And what we know about angles in similar polygons is that they are congruent. So the equation I'm going to write down is, I'm going to use angle t because, again, x is a part of angle t, and angle t is going to be congruent to angle A. Again, T is the second letter, and so is A. That's how I know that these two angles are corresponding. Again, because two objects are congruent, this means that their measurements are equal. So I can go ahead and substitute in angle T is 2x plus 8 degrees, and this is going to be equal to angle A, which is 95 degrees. Now from here, we just go ahead and solve using some algebraic steps. To get rid of that plus 8, we're going to go ahead and subtract 8 on both sides. This gives us 87, which is equal to 2x, because plus 8 minus 8 becomes 0. Last and final step here, we're going to go ahead and divide by 2 on both sides. 2 divided by 2 becomes 1, and so we are left with just x, and x is going to be equal to, you can leave your answer as an improper fraction, which is 87 divided by 2, or you can go ahead and convert that into a decimal, which is going to be 43 and a half. All right, so that got us x, or we were able to solve for x. Now we need to actually solve for y. So taking a look at where y is, we have y minus 11, and notice how it represents a side, specifically side BC. Because y represents a side, again, from earlier, we know that sides are proportional. So in order to solve for y, we need to set up a proportion. All right, so taking a look here, the side that contains y is side BC, and side BC is going to correspond to side UE. And then from here, we can go ahead and pick any of the other two sides, but notice how side AB doesn't have a measure. So it's probably best not to use side AB and instead use side AC, which does have a measurement. So side AC is going to correspond with side UE. Now we just go ahead and substitute everything in. BC is y minus 11 divided by UE, which is 21, is equal to AC, which is 7, divided by UT, which is 14. Cross multiplying. Be careful when you're multiplying 14 and y minus 11 because technically we're multiplying 14 with all of y minus 11. So please make sure to use those parentheses to show that. On the other side of the equation, we have 21 times 7. So because we are multiplying 14 with y minus 11 and all of it, we need to go ahead and we need to distribute the 14 here. 14 times y just becomes 14y, minus 14 times 11 is 154, which is going to be equal to 21 times 7, which is 147. Now, again, I'm going to point this out in case you would like to do it. You can go ahead and simplify this fraction before cross multiplying. This kind of helps us to use smaller numbers because instead of 14, I'll be using the number 2, and instead of 7, I'll use the number 1 instead. But it's not necessary, and at the end of the day, we will all get to the same answer. All right, so solving for y, I'm going to go ahead and add 154 on both sides of the equation here. And so we are left with 14y minus 154 plus 154 becomes 0, and this is going to be equal to 301. Last but not least, 14y, that's multiplication, so divide by 14 on both sides. (14 divided by 14 becomes 1. We're just left with y is equal to, as a decimal, you can go ahead and write it as 21.5, or as a simplified fraction, 301 actually does divide by 7, so we get 43 divided by 2. All right, so that is how you solve for both x and y, and also write a statement of similarity. Go ahead and pause the video here and see if you can try this problem on your own. Alrighty, go ahead and double check over your answers. The two things to note, of course, are to make sure that you knew which variable represented what part of the polygon. So z represents an angle, and angles are congruent. This actually was just one step. Once you substitute in, you know exactly how much z is. X, though, represents a side, and sides are proportional. So here's the thing. In setting up your proportions, we definitely, of course, needed to use side KL or side LK, which corresponds with side GF. But if you wanted to use side JM, the problem with JM is that it corresponds with side HE, and we do not have a measurement for HE. That's why we did actually need to use JK and EF. Again, double checking to make sure that you've distributed because you're multiplying 8 with 4x minus 3, the whole thing. Simplify it all the way down. We get 61 divided by 8, or 7 and 625 thousandths. Alrighty, so that is it for part 1 of your notes for 8.1. Go ahead and check out the video for part 2 if you need it. Thank you so much for watching.